All right, it's a little bit after 9 o'clock, so it's time to welcome you to the 2025 International Test Conference. This is the plenary session, and it's really great to see all of you. And fortunately, today, unlike yesterday, San Diego is actually sunny. So my name is Jennifer Dworak. I am from Southern Methodist University, and I'm this year's General Chair. And before I get started with the rest of the program, I want to send and give a great thank you to all of our corporate supporters. We could not have this conference without them by any stretch of the imagination. They, contribute monetarily, but they also contribute technically and on the exhibit floor, and it's wonderful to benefit from all of their generosity as well as all of their expertise. A little bit later, we're going to have a presentation in this room after the plenary from our Diamond supporter, Synopsys. And as you can see here, they have a wide array of speakers who are from multiple companies to come talk to you and give you important information on test and silicon lifecycle management. Then later today, our Platinum supporters are also going to give talks. That will be from 4:30 to 6 in Aqua Salon AB, which will be on the floor above. And so as you can see, we're going to have one presentation from Adventest and another one from Siemens. And then finally, our ITC sponsors are various technical societies. So IEEE, the IEEE Philadelphia section, and of course the IEEE Computer Society. And once again, there's absolutely no way that this kind of event could go on with all of their help and backing and expertise. One of the great things about ITC is that we have a very active steering committee. If you look at this list, you'll find that every single person on this list actually contributes greatly to the success of the conference. It's definitely not a one-person thing, and each and every one of them plays a critical role. So I definitely want to extend my heartfelt thanks to every single one of them. Okay, so ITC is not just a single day or single couple of days. It's an entire week of events that are devoted to tests. As you know, the first few days of the workshop, the first 2 days, sorry, not the workshop, the conference, involved tutorials, and we had 12 on Sunday and Monday. We also have 4 keynote and visionary talks. There are 3 keynotes that you'll see this week, as well as 1 visionary talk. And we have 4 parallel tracks, which will have 45 regular and short papers, as well as a variety of special sessions and really interesting panels. I hope some of you got to see the panel yesterday where AI was actually one of the panelists. That was both very instructive and very fun. And so if you missed it, talk to somebody who was there because it was very cool. We also have a large number of posters this year. There are going to be 64 posters in the exhibit hall, and we have 19 exhibitors. We also, as you saw, we have corporate presentations, and then on Friday, end of the day on Thursday, we're going to have 2 workshops. And it's still possible to sign up for those workshops if you haven't yet. So if you're here and you like what you're seeing at ITC, please consider signing up for one of the workshops. As you notice, we don't have paper programs because we're trying to get into the 21st century. So as in the last few years, we're using the Whova app. You should have gotten an email which encourages you to download and shows you how to essentially register. You can create an account if you've never used Whova before. If you've used Whova with multiple email addresses, as I have, then make sure you swap to the email address you signed up for ITC for. But basically, it's a very helpful app. The entire program is there, as well as a bunch of other abilities to do things. So, one thing you can see here, and I don't know if I can see. So basically here you've got the leaderboard, which shows how active you are on the app. It's good for socialization, but as one of our steering committee members said, don't spam people. I guess there's no prize for being the top person on the leaderboard. You just get bragging rights. On the other hand, some other things do have prizes. So over here with photos, there is a photo contest, and the prize for that will be a mini cam. One thing that you definitely want to do is use the passport function. Okay, so basically this will give you a QR code, and then when you give it to the exhibit floor, or go to the exhibit floor rather, as you visit each of the exhibitors, they can essentially scan your QR code, and people who have visited the right number of exhibitors and interacted with them will essentially be able to be eligible for a drawing to win a prize at the end of the conference. Okay, so that will be announced on Thursday afternoon, but if you had a flight to catch, it is still possible to win. So please visit the exhibit floor and talk to all of our exhibitors. There's also a trivia contest starting Wednesday for an earbuds drawing, which is and that drawing will be Thursday afternoon. And then finally, we have surveys where session feedback on those surveys will replace the yellow cards that you probably remember, which were never turned in all that religiously anyway. But the idea here is that if you can give us some feedback on the sessions, that's really helpful, both for us knowing what is of interest to the community as well as to rank the best papers. Okay, so with respect to the conference, we are actually on 2 different levels, so just to make it easier if you haven't had time to look at all the details of the Whova app and where things are, I'm going to show you those. So right now we're on the Indigo level, okay, and so right here, this is where we are. We're in the plenary, so congratulations, you found it. Right next to us will be all the exhibits, so like I said, make sure that you go check all of those out after the plenary. And then here, this is also where we'll have other keynotes and the visionary talk. For above us, we have the Aqua level, and this is where all of the normal technical paper sessions and some of the special sessions and panels and stuff like that will be held. And so you can see here, there's this set of rooms, so A, B, C, D, and then E, F, that are all going to be up there. So basically, you'll be on one of these 2 floors for the conference. There is a welcome reception tonight, so please attend. It's going to be from 6:30 to 9 p.m., and basically it's going to be just outside those doors, right? So right here we've got the Indigo West Foyer, and that's where you'll find the welcome reception for the conference. Okay, and then finally, when you go into the exhibit hall, okay, so like I said, that's right next door to us. You'll find several different things. So you will find the exhibits, and you can actually, if you're looking for a particular exhibit, if you use Whova, you can find a map that shows where all of the booths are located. But like I said, please visit all of the exhibitors. We also have posters. And as I said, there are a lot of them. I assume that most of the poster presenters are already here and have brought their posters. You are allowed to put the posters up today, no matter when you're going to present the poster, and just leave it up for the entire conference, right? So that way, even if you're not there standing next to it, other people can appreciate your work. So we encourage you to do that. And then lunch and coffee and stuff like this will also be in the exhibit hall, and so that will be an additional thing that you definitely will want to check out later. All right, so one of the things that ITC has also been doing, much more than sometimes in the past, is to be present on social media. And so if you look up here on the top right corner of the webpage, you can see links to all of the social media pages. I mean, I know, for example, that we have significant posting on LinkedIn, but yeah, please follow all the ITC social media so that you can get up-to-date information on what's going on at this conference and also for next year's conference. So things will show up there, before maybe they even show up on the website or in emails or anything like that. So you can hear up-to-date information about keynotes and things like that for next year. And one of the things that's really important for a conference like this is marketing. And so I want to make sure to give a big thank you to our marketing committee. Ron Press has been has been in charge of the marketing committee for multiple years. And he manages our website. He and Charles will do most of the mobile app, social media announcements. He's always asking us for more content so that he has more things to post. But yeah, so basically anytime that you know what's going on at ITC, it's because of Ron and his committee. So yes, a big thank you to all of them. Okay, now another thing which is true about ITC now, which was not true when I was a student, is that it's not just this conference in the United States, it's actually a worldwide electronics test community with multiple sister conferences. And in particular, ITC India and ITC Asia are our sister conferences. And so one of the things that ITC India asked us to do is to tell you about their conference. Like I said, they're one of our sister conferences. They had a great success for their 9th conference that was in, I don't know how to say that, Bengaluru, India, with tons of registrations and a hackathon. And they also have a new call for papers, and that's actually the main reason they want me to tell you about this, right? Oops, sorry. Go back. All right. It won't let me go back. So, but you remember what it is, right? So basically they had a call for papers, I think it was between November and February were the deadlines for paper submissions. So, you know, please check them out online so that you can potentially submit to them too. And now I want to invite our program chair, who has done an incredible amount of work and is probably one of the most organized program chairs we've ever had, up to the stage.
Thank you. Thanks, Jennifer. Good morning, everybody. It's my pleasure to be here as a program chair. Great honor. And yeah, I have to say thanks to a lot of people, in particular the PC members who did a great job. We got quite a lot of papers, and that means a lot of reviews, a lot of work. And we organized the program preparation in several steps, so it was not just a single meeting, but a lot of messages and a lot of discussions about the selection of the papers. Many of them have been accepted full paper, some short, some poster, and that was merit of all these people who really did a great job. We have 86 PC members this year, but I want to acknowledge also the sub-reviewers. They are quite a significant number, 35. They are all listed on the website. Then I'm very grateful to all these people for their work. And in fact, here you have some numbers about the review, the selection, and the organizing process. Overall, we got 164 regular papers, then followed by 80 posters. We were able to accept not a big number. You have on the website also the acceptance rate, which is lower than 25%, so very selective. I was sending about 1 million of email messages. You know, if you are one of the authors or moderator, you got very specific instruction from me. I hope it was not too heavy and you managed to follow my crazy instructions. We had a very long remote meeting, 9 hours in May timeframe, and a lot of steering committee meetings that happened mainly during my European night, and we had a lot of fun organizing the conference. Overall, we collected about 1,000 reviews. It's a little more than 900, and I think that was really a good success. In the end, I don't want to repeat what Jennifer already discussed, but you see here a summary of what we will see in these days. Many panels, many special sessions. We have a student track that is kind of novelty for ITC with 3 dedicated sessions to PhD students. We will start with keynoters today, and we have an AI track composed of 5 sessions. We have a lot of AT contents, emerging technologies, automotive, and a lot of also miscellaneous topics in the poster session especially. About the program, the authors and moderators already received a lot of information and instructions, but I want to stress the attention on the delivery of your slides if you are an author and you have to speak. We have a room at the 3rd floor, 3rd level, room 303, where you can deliver your presentation. It will fly directly in the room without any necessity to deliver at the last moment to the moderator. And moderator have the bios in the EasyChair page. If you browse the EasyChair and you click on the presenter's name, you will see their bio and picture appearing, so they should be also easy to identify if you want to share more thoughts during the conference in general, not only as question after the presentation. Right, I'm gonna finish. For us, it's very important to receive your feedback, and the WOVA application, the WOVA app, can permits you to enter your comments to every paper, to every session. So don't forget that. It's important for the best paper selection too. And in fact, I will leave now the podium to Yervant and after to Savita for the awards this year. We start with Yervant, and then we continue with the best paper awards with Savita later. Thank you very much for attending. I'm very happy to see you here, and I hope you will enjoy the conference. Thank you very much.
Thank you for the great work. The whole steering committee did a wonderful job. Jennifer, Paolo, your introductions are very insightful. I see lots of familiar faces, but many new faces as well. I'm very happy to welcome you all on behalf of TTTC. TTTC is the Test Technology Technical Council, the family of our community. And this community itself is full of activities, interactions, mostly volunteer work. We have many volunteers all around the world that participate in different offerings, in different generational activities, student activities, more activities for the industry, for academia, standards, publications, conferences, tutorials, as you have seen. So we have a wide range of activities that go on around the year, and topically they are distributed as well. Today, Jennifer was mentioning 2 sister conferences. I wanted to go a little bit beyond that to show you that while we started our efforts as a community in ITC, our flagship event annually, and still it is the main event of the year where we all come together, we also added geographically other events around the world that also cover various aspects of test, of reliability, of diagnosis, repair, safety, security. VTS is one in North America. We do have, we proliferated to other places outside the North America, to Europe. Years ago, we started DATE, we started ETS, as well as East-West, DDAX, and we continued to augment over time. In the early 90s, Asian Test Symposium, then Latin American Test Symposium, and we proliferated to our 2 new sister conferences, new being 7 years old, ITC Asia and ITC India. All of them serve the test community. We have all of this because our community is well distributed now. We have lots of presence in many countries. We need to serve them. Now, it's not only this. Many of those events are not the conference only. They have lots of additional peripheral activities around them, topically concentrating on new topics. For instance, at ITC, the 2 workshops that we had this year coming on Thursday, Friday are the SLM workshop, Silicon Lifecycle Management, as well as 3D test and repair with chiplets. Both are very timely topics. That's why we see lots of interest, lots of participants from industry and academia. Similarly, at ETS, we do have multiple workshops that go in parallel, such as eArts. At DATE, we do have multiple workshops as well. So these events are not just a conference, they're also enriched by additional topical domains. We also have topical events outside those main conferences on top of them, such as the RAS Summit, the Reliability, Availability, Serviceability Summit that we will have in November. We had it last year as well. So all of these together serve our community, make us learn from each other, and advance our field properly. Now, moving forward, I would like to mention a few things here, which we typically do. One is the Lifetime Contribution Medal. Lifetime Contribution Medal is the highest level test technology dedicated medal that is given to an individual who has done prominent work in the field over the years. In past years, we acknowledge several individuals in our community, senior, very well proliferated, and gave us lots of wealth to our community. So this year, we'll be adding one more prominent person to this list to become the new Lifetime Contribution Medal holder from now on. And that person is someone familiar to you, a person who has done a lot to our community over the years, and that is Irit Pomeranz. Irit, over the years, and as we know her like this, she gave us a lot from the early days that she joined academia. She did her bachelor, her PhD in Technion in Israel, and then came to the US, worked in Iowa University of Iowa that is. She worked at Purdue for the last 25 years, and she has given us a lot since then. Today she has a Cadence professorship at Purdue that she holds, but her contributions were fundamental from the basics of test, from structural, functional test, to the most advanced topics, such as silent data corruption that she does today. With that, she covered lots of it with her graduate students, many PhDs, numerous master's students that came, and very impressive, a huge number of publications that she donated to all of us. 340 journal publications. In addition, 400 conference papers. Not too many people have these numbers. So she really fed us a lot with her content, and with that, she became the first feature author on IEEE Explore. When IEEE Explore started to show feature authors, she was the first to hold that. And she got, of course, Best Paper Awards from multiple conferences. She was recognized by the National Science Foundation as Young Investigator. She became IEEE Fellow a long time ago, 26 years ago. She was the program chair of Fault-Tolerant Computing Symposium. She was the program chair twice for VTS, and then the general chair of VTS, therefore served the community through our conferences as well. Also ICCAD. She's very active in journals. She's part of the editorial board of ACM Transactions on Design Automation, Transactions on Computer, Transactions on VLSI Systems. So with all this work, Irit received several awards, including Outstanding Contribution Award from Computer Society and Golden Core Medal from Computer Society as well. And if you search her on the ranks for scholars, you can find lots of very impressive numbers for what she has done before. We're thankful to Irit. We're thankful for her being a leader in our community, being an innovator with all these contributions, being a pioneer in various aspects of test, and having a lasting impact on our community. Irit, congratulations.
I want to thank TTTC for this incredible honor, and I'm glad Yervan showed you the list of previous recipients. To be one of them is just simply incredible, so thank you.
Thanks a lot. Thank you. There is another award that we typically give it at the opening of ITC. It's a very important one as well. It's an award entitled after Bob Madge. Bob Madge was a member of our community. Unfortunately, he departed early. He promoted a lot, collaboration, research, collaboration between industrial partners, between industry and academia. And in his name, we have established this award. It's a TTC award that is given every year to an individual who has contributed to our community, again, with results. So this is results-based one. We have 11 years that we're giving this award already. And this year, the recipient is Harry Chen. Harry Chen, congratulations. We all know Harry for many years. He's the father of system-level test to me. He has done a lot in heterogeneous integration domain. He has been in silicon-to-system profiling analytics. He has published 20 IEEE papers in our conferences, ITC, VTS, ATS. He is the co-chair of Semi-Taiwan Test Committee, as well as he collaborates with various universities with his work. Harry, congratulations. There's another award that I will not be handing it today because it's not finished yet. It's the Best Doctoral Thesis Award, which is named after Professor McCluskey. This award is for the best PhD thesis, which goes over 2 steps. Semifinals happen in other conferences around the world, our conferences, and then the final happen here. The competition itself here at ITC will be tomorrow morning, if you like to attend it. So there'll be the finalists from VTS, from ETS, and Asian Test Symposium to be present, and the judges who are dual from industry and academia will contribute to the selection process, and we'll find the winner. On Thursday, I'll be happy at the opening session to hand the winners of this year award, the winner, that is one PhD recipient. So we'll wait for that together. Please stay connected to TTC with all the activities that we do. You have various ways through social media to follow us and be able to be active as well as volunteer. Thanks a lot. Thank you. Now it's my pleasure to invite Savita to the podium. Savita was the program chair last year, and she'll be helping us with the Best Paper Awards from 2024. Savita.
All right, this is truly an honor to deliver these awards. It was quite a process to go through all the content, and basically it was, as Paolo just reported it, we go through an extremely rigorous process to evaluate all of the submissions. And so anyone who was selected to participate and showcase their work at this conference should be celebrated. But this was truly an additional honor. We assembled a committee that reviewed all of the top papers, but we had a lot of metrics of novelty and overall impact of the contributions. We actually assembled a group of a panel, a group of the committee was assembled, and they pretty much didn't know who each other was. So it was not like a conclave, but almost close to that. So with that, we have 2 honorable mentions and 1 best paper. So I'm going to call out who was selected, and then I'm going to invite the authors to come and receive their plaques. So the first honorable mention goes to a paper entitled Digital Scan and ATPG for Analog Circuits, which is great, by Steven Suttner and Christoph Jurga. Sorry, tends to be a little bit awkward. We didn't rehearse this. All right, the next honorable mention is Generation and Quality Evaluation of Synthetic Process Control Monitoring Data by Matthew Nye, John Carulli, and Jurgis Marquez. Oh, no, you guys should be up there. I'll just be casual. Sorry. Thanks. Thank you. Congratulations. All right. And the Best Paper Award goes to WM Graph-Based Approach for Wafer Map Analytics by Min Yang, Jenny Zhang, and Lisi Wang. All right. And Paulo will come and introduce our keynote speaker.
Yeah, it's time for the first technical speech. It's given by Richard Rodell. Richard has been in test engineering since 33 years, working in multiple roles, from development of VP of test engineering, and he has worked on a wide range of products from memories, complex SOCs, advanced analog, and RF. He has a long experience, and I will leave the floor to Richard to give his talk. And yeah, I hope you will enjoy. Thank you.
Good morning, everyone. I'd just like to say it's an honor and privilege to present to you today. I hope to show you something that I've been working on personally for probably 15 years to basically drive this together. So what we're going to talk today about is the test development ecosystem. So an ecosystem, is fundamentally an entire tool, an entire environment of tools, technologies, practices, and communities that support a creation, deployment, and maintenance of a system. In many ways, if we compare a test development environment to a biologic ecosystem, we see a lot of similarities in that the parts are interconnected. You can't have a standalone tool. It's the connection of tools. These tools evolve together. New frameworks rise, and the old ones die out. And that's really what we're going through now, is a much faster evolution of this framework than we've seen historically. And they adapt to external forces, whether it's climate change. In our world, we're kind of going through a climate change event right now with regards to AI and how we think about our jobs, how we think about what we do every day. And then there's a large amount of balance and compatibility. You can't rely entirely on one system. For the sake of this presentation, I'm going to talk about the test solution as a whole. And this really starts from silicon, the design, the DFT insertion to that design, the hardware development, the test program creation, even integration with the handlers and the probers and the sockets. It's the entire test solution that we have to look at during the development process. And so today I'm going to look at the evolution of this system and I'll look into the future. So when I started as a test engineer, a lot of you, at least the older people, would recognize some of these systems. And my first chip, I was the test engineer, I was the product engineer. And, my world basically revolved around an oscilloscope and a CRT. And, the programming languages were very, antiquated. I mean, this was 30 years ago. And everything was single site. So, it was a very, very, call it simple problem. If I fast forward 15 years, this is when we really started to drive into, say, complex SOCs, at least in my company. And the average test program had at least 5 test engineers. We started going into the world of offline and online development where we could basically emulate, simulate, build offline. ATPG was something that was like standard by this time. And we really got into, standard revision control. It was sort of interesting. At my company, we didn't introduce like Subversion or ClearCase until, 2007. And so, revision control at that time was still just file naming conventions, RIC 1, RIC 2, RIC 3. And it was like you couldn't figure out what you'd done. And, with the introduction of the, Nextest Magnum here, we finally got into like C++ programming, which allowed us to go into like an object-oriented approach to how we program. And probably the biggest change was how we were able to execute on debug. We finally had the ability to VNC into our systems, either locally onto the sort floor or into another location geographically. And from a debug perspective, we were able to see things via this virtual window, whereas historically, everything was with an oscilloscope. Everything was very hands-on to figure out how it worked together. Now in 2025, things have advanced much further yet. As now we're seeing, at least 10 engineers on every chip, in some cases as many as 100. We still have 100% online and offline development, but we're basically seeing continuous advancements in ATPG. We've heard a lot about that, in the conference and how patterns are growing and complexity's changing. And we're getting more advanced DFT techniques, which basically are allowing us to see inside the chip better. We're also seeing that style and protocol aware are becoming sort of de facto pattern languages so that it's much easier for us to interact with our testers. We have advanced revision control, and what I mean here is we basically are running multiple branches. We're branching and merging, and it's very advanced in terms of when you branch, when you merge, how this stuff fits together. And we see fundamentally the emergence of 2 programming languages that are dominating our test development world, and that being Java and .NET. And of course, everybody has a very strong, understanding of Python, and so the jump to these 2 languages is very natural. And probably the biggest step forward that we're really driving is, adopting to a CI/CD flow. And that is we need to do continuous integration and continuous development deployment. And we're seeing tools like, Jenkins is old, it works, but we're moving into things like GitLab, where it basically gives you a much better environment with like GitLab Backstage, GitLab Duo, and other tools that are available, from third-party companies. And we're seeing that the IDEs are truly getting to be a true development environment. And so through the IDE, you can fundamentally see what's happening. You can see your instruments, you can see your flow, you can see your sequences, you can see your test time, you can see all this stuff. Whereas before, it wasn't native. And finally, we're getting integration of our first generative or helpful AIs with the integration of Copilot into our IDEs. And that gives us a lot of benefits. And it's very interesting if you started using it, how much it knows, because our test programs by definition have a lot of context that can be linked. So as we go into this digital transformation, we see this, in the last 20 years, a big transformation. But just to kind of zero in on to like the 2030, 5 years from now, can we get to like sort of fully autonomous testing systems where it's basically looking at the results and dynamically feeding back into the system to basically, toggle those results, change those results. We're seeing AI-driven, and something I'll get into a little bit more of here, predictive real-time insights. And so as we're drilling into this, how do we think about what do I look at next? How do I generate that first level of Pareto at first silicon to see what do I go work on? And the other thing is we're seeing is much more advanced digital twins. And a digital twin is fundamentally that correlation between online and offline development. We're driving more and more so the offline environments and the offline results emulation is much better than it was long ago, and it continues to grow there. So how do we get simulations to match silicon? How do we get the test program to be emulatable? Things like that. So the storyline for test engineering in Infineon, and I think it's true for the industry as well, is where are we? Each test engineering organization has their own custom test development environment. Methodologies in those revolve around their perceived needs. You always hear, well, I'm doing FinFET, well, I'm doing a PowerMOS, I'm doing this, I'm doing that. And so they drive around those. And what we see is some groups, like our automotive group at Infineon, has expansive frameworks, while in other groups it's still ad hoc. Think of even pre-2010 where I showed it there. A single test engineer, limited debug, etc. And fundamentally, we've hit a roadblock where unless we harmonize this tooling, methodologies, and framework, we're not going to hit our productivity requirements. It's just not going to happen. And so how do we get there? So what I'm doing is we're defining a framework that's deterministic and to a certain level tester agnostic. There's a lot of things that we do that are not tester ATE dependent, but they are very specific at the implementation level. And so I don't want to basically say you can test anything anywhere. Of course, that's a complete falsity. And we want to develop tooling around the software industry's best practices. The software industry is moving at light speed, even faster than every 6 months. I thought I knew what was going to happen, and 6 months happened, and I was wrong. And so we need to basically get into a fast follower mode with the software industry as we develop our test programs so that we can learn and adapt as quickly as they do. We're using a protocol for universal test specifications. Right now, I'm grabbing all the information from all my designers and porting them to something like JSON, which in .NET and Java and Python, you can read JSON in one line. And then using a universal pattern language, whether it's style or protocol aware, and basically abstracting that away from how the tester's implementing that to make sure that we have clear understanding. And then we're structuring our test methodology with a real focus on reuse. My question to every one of the test engineers that's ever worked for me is, why are you developing that? Why aren't you using something copy exact? And we see a lot of challenges with copy modify. And everybody's doing copy modify, and it's like, why don't we just copy exact? And so again, we need to get to that point, and we've proven that on platform products where you have 15 die running the same technology with different combinations of IP. And lastly, we want to automate the test program generation. And it's not, to be very clear, this isn't generating a perfect test program. It's not even close. But what it's doing is it's creating an environment, it's creating that ecosystem that allows us to get a test program that's functional, that works, that builds, and then we can get to work. I mean, our engineers spend too much time, and you guys spend too much time like fighting with the test program. You want to fight with the silicon. And so where do we want to be? Fundamentally, we look at that above, and I'll go through this in the next pages, and develop an architecture around that. We want a universal test specification that's digestible by AI tooling. What I mean by that is it's presented in a format that AI can easily create the tokens and link the tokens together between specifications and yield, specifications and this and that. And we actually have that nodal analysis already done in our industry because everything is natively linked. If it's not, there's something wrong with your test program. And then we want multi-platform portability and a certain level of test commoditization. And it doesn't mean, instantaneously platform A to platform B, but it allows us to see what is the benefit of going from current generation to next generation tester quickly. And understanding how is that going to create productivity across all of those aspects. And lastly, I think we need to synergize across the test engineering organizations within our companies, but also as an industry, understand how do we basically build a system that's basically going to allow us as an industry to move forward. So we developed something called United. It's just an acronym. But what we see here is kind of some components that build our test program together. I'm not going to go into all the details, but the test package lifecycle management is really how do we go from first silicon, pre-silicon, to mass production and understand how that life cycle happens, from generating our test program to doing offline simulation and debug, to doing online debug, to optimization and through. Understanding what our universal test spec looks like and where it resides. At my previous company, Cypress, before we were acquired, we tried to extract this information from paper. They're electronic specs, but they weren't in a database. It was a complete disaster. Now we're basically driving all of the specs using like a requirements-driven design flow to basically have those specs in a queryable database. We need a pattern management platform. Patterns continue to evolve, optimize, change very dynamically. And we need to be able to manage the patterns such that we can understand how they're evolving over time in coverage, in space, in test time, in creation, conversion, integration. And lastly, from a test package bill of materials, this is really about as I go through this development, how do I create all of the appropriate artifacts so that I can learn? Many times as we develop our test programs and then we go to learn, generate learning feedback, it's very challenging for us to find cause and effect just using memory. And so my hope is that as we grab all of this data, we can actually ask our AI partners to summarize this information and get us to a level where we can then talk as people and figure out what the most impactful things were. And as I mentioned, the key here is that we evolve around a software industry approach. And so I just threw in some tools and names. I think the most important area is really how do we generate reuse, regression, and control in that area. But on the other side, it's like in the lifecycle management, we're using things like low-code and Tableau to generate dashboards and visualization. We're using pattern management tools and conversion tools, both internally developed and using, vendor tooling. And we're basically generating through our program release and regression cycles this, test package bill of materials, and that's going into an Infineon test data lake. And that's a combination of data sources. So as I mentioned, the most important thing that I see is establishing regression flows that are both standardized, scalable, and they do call it the work functions that we need it to do. And so generically, the regression stages are, from left to right here. Basically, you have your source code management, all your different block repos, your shared libraries, all your specs and everything. And then you're going to build and audit that test program. In my world, this is really about configuring the test program and then aligning, the flow and the configuration of that. So the automated test program generation is not code generation. It's generating, an IG workbook. It's generating a .flow file. It's generating a .spec file. And the code itself is still sitting in your test methods and your test instances and whatever you write there. And we build and we load and we audit that program. And when we audit that program, we use things like SonarQube or Spot Bugs or something even customizable that allows us to grab information from that process. We then run the test program offline, online, and again, we have multi-branch, so we can run different operating systems. We can run different targeted flows if we're just targeting our scan DFT flow versus targeting the whole flow. And then we analyze those results, and we basically look at those. We've done a lot of work on like Q-score creation, which is looking at repeatability, test time targets, and basically trying to adapt to where it basically gives you a good representation of is this test good or not, and then the sum of those, is this test program good? And in this analyzed results, we're also trying to quantize and quantify the coverage. And lastly is we archive this information at the end of each of our regression so that we can basically see in time, how are things progressing? Where are things progressing? And what we've seen on like our platform designs is that there's a lot of static code and static portions of the test flow. And then there's these other portions of the test flow that are incredibly dynamic. The scan bring up, the non-volatile memory debug and bring up. A lot of those things, you see a lot of churn there. And so in this archive, we can basically go back in time and basically say, why are you touching the ADC test? This has been released. Why isn't it working? And so it gives us the ability to look into that. And so now as we look into, the future of how we can interact with this ecosystem, is historically, and even today, we had tens of different tools. And none of them were tightly coupled. And at Infineon, there are tools upon tools upon tools within the business units. And they never even talk to each other. And so there's very limited connections there. And then the last 5 years, we've seen a much better self-service sort of portal solution where you can go get work done. The easiest one for companies and stuff are just all the HR portals. But we don't really have test engineering portals, like, oh, I need something new, please deliver this to me. And we've played around with that. But what we're seeing now is really moving into the area of like orchestrator AIs. And you can think of an orchestrator AI where it's basically functionally interacting with all the pieces to basically create your ecosystem. So you could sit down at your system as a program manager, as a lead test engineer, and basically say, I want to create, a new test program, create a new ecosystem for this product, use this product as my reference, this and that. And the orchestrator will go out and it'll set up a GitLab regression. It'll import and set up your SVN externals or your submodule linkage into whatever things you need. It'll create other content that you've enabled through this orchestration. And it'll basically get you to a point where you can be a functional test engineer, in a day. And that's really where things are moving, and we can see this orchestrator AI happening in other areas. If we think of where we are with agentic AI and with orchestrator of these agentic AIs, is we basically see that agentic LLMs are like a new operating system. They're not like a standalone tool. It's like, this is the operating system that we work within. And you can see this from a Google perspective and how you have all of these interconnected operating systems running through Gemini that allow you access to photos and email and a calendar and this and that. And this is really where, as we think of this, it's like, how do we get to a level where we basically have a pseudo-agentic ecosystem? And so a solution that's come out recently, in the last 18 months, and it's gotten a lot of traction, and since it's in the AI space, in 6 months it'll probably be gone, but there'll be something very similar to it. And that's something called the Model Context Protocol. And the analogy that they've given a lot is this is like the USB Type-C for AI. It's designed to provide more deterministic interactions. So like if you're talking to an EDA tool, it doesn't care about these topics. If you're talking to the tester, it's really thinking about the tester. And what we see is this MCP is a standard interface that allows the AI models to connect to external tools and services dynamically and intelligently. And so just like on the right side there, it's like, what can we plug into our system? And what do we point that to in terms of LLMs to get the best performance? And then downstream from that, how does that link up? And so an MCP server is really listening to requests from the MCP client. And so the MCP client is anything like your IDE, like Copilot, Claude, self-delivered tools. And it's basically providing a service. And so basically the MCP server is looking for like a prompt template. Like it's looking for key things that are going to come into it. And based on those key things, it's basically going to access the data, the file system, the database, things that you want it to. And then it even gives the ability to provide a function and return back a higher level answer. And so this allows us to basically have MCP servers that are supported by our vendors, like the EDA vendors, the ATE vendors, and then also local MCP servers that allow us to talk to our yield information, talk to our design information, talk to our register maps, and things of that nature. And the other thing MCP brings, and this is kind of a point of contention, is you can actually have an MCP server serving something off-prem. And they have some things in place that allow us to have secure protocols over this. And this is really where I think it's evolving, is how do we differentiate and how do we drive on-prem versus off-prem learning? Because if you're sending context, you're sending data. And in all honesty, the Copilot doesn't care what it sends, it just sends it all. And then it's looking for a return, and then it kind of summarizes that, and then it sends it back, and it keeps doing that until it converges. And so you don't really know what's going, and you can put a sniffer on there and watch it, and it's amazing the amount of information that it sends and how many tokens are going. But it basically gives you this ability to structure this. So in the test ecosystem, at the top are ideas of possible MCP servers. We have all of these things, and these connections basically enable the ecosystem. And the ecosystem drives the structure of this data. How do we capture this data, put it in a place, where the MCP server is actually looking at it? And then the structure ensures scalability. In the beginning, like with everything, we start with one simple server, and then we basically figure out, like, as a company introduces a server, as another group within Infineon introduces a server, how do we generate that connection? And then down below are just sort of some ideas of, like, what am I looking for from an insight perspective? So like yield improvements, you're looking at the absolute yield, of course. You're looking at your test program. You're looking at the ATE. You're looking at the design. You're looking at the characterization data. And very quickly, by pulling all these things together, you should get some insight that basically says, the characterization data showed this number. Your data is showing this number. And so the future of AI isn't about better models. In all honesty, we've seen the models that exist today are as good as the data. Like, we haven't had a model problem, we've had data problems. And the models are only getting better. And so for us, it's really about how do we create this data capture and this ecosystem that allows us to then prompt the right information. So, what is the new normal? Historically, we always had, product engineering, test engineering, characterization engineering. Depending on the company or the organization, there's always overlap and things like that. But, in the future, it's like, can we connect these things into one sort of source so that we can get this information more tightly coupled and derive those critical insights from that information? And I think the answer is yes. The test engineer is still responsible for the test program, for creating the information, for understanding what the coverage is, understanding all of that thing. But more importantly, they're also required now to create the data that can then be shared via these connections. The other new normal is sort of these vertical use cases. On the bottom right there, I think every engineer in this room has been here, right? The silicon, the design engineer says it's a yield problem. The product engineer says it's a test program problem. The test engineer says it's a design problem. And so you continuously have these cycles of learning. Well, give me a new pattern. Well, it still fails. Do this. Well, it still fails. And what we see here is, especially when we get into platform design, it's like the design engineer can actually go in and say, how is my SAR ADC performing across all of the designs it's been implemented in? And it could pull all that information for the design engineer and give them that first level Pareto, and then they could basically drill down into it. For reliability, you get a customer return. You can ask the system, here's the data log of the failing part. What happened during the test program development that is in relation to this specific failure mode now? And it could basically look into that revision history, look into the artifacts that we've saved, and basically say, the voltage was changed on the MBIST, hot temp insert, blah, blah, blah. And from there, it basically could give some insight and get that first layer of communication happening so that as the customer return came to the product engineer, came to the test engineer, they would have a much more insightful starting point. And this extends across multiple areas, whether it's firmware, system validation, et cetera, et cetera. So I just wanted to give you kind of a real-world example that one of my engineers did here. And he literally just took an STDF data file, just a random one. It could be one that you have on your laptop today. And what he did is he just created a couple of MCP calls and environments. And so what he did first was he basically took and he ran a script that basically created an STDF kind of pre-processing that creates sort of the token environment of the STDF. He then ran a clustering scheme that basically, what it does is it links all the things together from a tokenization perspective. And then he summarized all the failures. And then what we did is we took the .flow file from the 93K program that this was run against, and we ran it through a program called Neo4j. And what it's doing there is it's creating for the test suite, it basically knows here's the test name, here's the conditions that were in the test program, and that information in there. And then he just ran it into our MCP client, the GPT for IFX, our internal node, and had it create an HTML report. And I have the full report, but I just thought I'd show you some overview things. It's okay, it says, this was the session, this was our test time, and then from the critical insights, it basically looks into a test name, and it gleans some information in terms of site variability or this or that. And what's interesting here is this was a complete blind So it didn't know anything. So in our regression flow, we could easily take every STDF file that's ever created and create something like this, which then is digested again by AI to basically summarize trends. And so this takes seconds to run, and it took a massive STDF file and basically found some site-related issues associated with a specific test. And if we had more information feeding in here, like the design, the test procedure, something, it might even be able to give us insight into what the characterization data was, what this was, what that was, what's the CPK. If we had access to the yield information, we could see, is this a trend or something new? But again, the goal of this is not to give answers. It's to zero in on what to look at. And so I was in the panel yesterday with Miss ChatGPT-5, and I thought it was quite funny, but a lot of the questions we asked her, I fully didn't expect it to answer correctly, and it didn't. But if you asked it questions about data sets and how data sets are connected to each other, it does a very good job. And so you have to be careful as to what you're asking AI to do. It's never going to be, it's artificial intelligence, it's not intelligence. And I think yesterday we were asking it intelligence questions, and it didn't have all of the information to be intelligent. So going back into our overall test development ecosystem, as we basically see some of the tools and attributes associated with these different pillars. And I think, when we look at the universal test spec, especially in this day and age, is everything is IP, chip, platform, technology specific, right? And so how do we have universal test specs that allow us to look at the commonality across all of those things and make sure we have sharing? We see a huge amount of pattern management, whether it's protocol aware and register settings, making sure that we're using the correct register settings across an entire family. And then, SSN brings in a whole another element of how is the test time progressing versus the coverage, and is there any sort of, patterns in there that we can't see through the data. And I think the most important thing, and what I'm driving to first and foremost, and we actually just got it running 3 weeks ago, is really the use of regression in a structured, deterministic manner. And this allows us to basically create dashboards with these things like Q-scores. It allows us to get automated insights into not only the regression itself, but the data created by the regression. And it allows us to create more linkages in the regression flow. So on the first few pages, I put together like 4. It's actually coming up here. There's 4 boxes here. Depending on the chip, depending on the company, depending on the tools available, this pipeline could be 20 stages, or it could be just a few. And down below here, we basically see, we're generating the test program, we're building the test program statistics, we're auditing the source code and reading that back. We're looking at test times. We're scoring results and highlighting problems and insights and successes. And archiving, we're building a history. And the other thing that I think we all do well as engineers and we focus on is, root cause corrective action. How do we get to true RCCA when we have so much churn and so much, so many inputs? And that archiving also leads us to best practices. As we look at a new chip, it's like, what is new from a test program perspective? Is the test program actually exactly the same, just different patterns? Or is there something fundamentally new? Or is it really a challenge about hardware, and the actual hardware creation to deliver that power? And so it really allows us to drive to best practices and make sure that we use what's working and only enhance, modify what isn't. So going back to this ecosystem view with the MCPs, it's really creating deterministic communications between critical areas. And that deterministic is really important. You need to have the ability to narrow what questions are allowed to be answered by which servers. Prompt driven by standard use cases. Prompt engineering is a big thing, and we need to understand when I ask a question and I get the wrong answer, what is the fundamental reason for that wrong answer? And I think as test engineers, AI didn't exist in this form. And so I actually asked, we had a speaker from Google, and I asked him, how did your team use Gemini from day 0 until today? And his answer was perfect. He basically said necessity. And I'm like, well, what did you do if it gave you wrong answers? He's like, we learned how to train it to give us the right answers. And he's like, and that's just this continuous feedback loop. And then we're using standard LLMs to create insight. We don't see the need to create LLMs. There is cases, I think, especially in, call it the vendor space, like an EDA tool, they may want custom LLMs that are basically targeting very specific things and how it's presented to those within their small database. But in terms of at my level, at the Infineon level, we don't need custom LLMs. So again, the future of AI isn't about better models, it's about the connections. So in summary, the ecosystem for me is really a basement and a foundation for test development. When I talk to vendors, when I talk to engineers, when I talk to designers, it gives me the ability to ask them, like, well, where in your development process did it break? Where did this data come from? What were the expectations at that stage? So it turns into like the way we work. And it also helps us communicate what we're working on, like what's working, what's not working. It's how we do analysis and form and drive learning. And so it basically allows us to plug things in. In the beginning, maybe there's just one MCP server. And in 10 years, we might have the equivalent of 50 MCP servers. And then the ecosystem captures that data to drive the future. It's really about how do we capture that data, because odds are this whole ecosystem is going to blow up in a year, and we're going to have to do something different. But if we've actually captured the data via this ecosystem, we can then basically say, my framework definition that I just shared with you was wrong, and what are we going to do differently? Well, we've got all the data. Let's overlay this onto that data and see what happens. And I think the new normal is really about driving convergence of skills and getting better alignment to questions. What is the problem? And sometimes the problem that we have is defining the problem. It's not actually, solving the problem. It's like we can't really define exactly what the problem is. And then once we all agree on the problem, then we can start working on it. And I think part of that comes from like the design engineer is thinking like a design engineer, the reliability engineer is thinking like the reliability engineer. Us test engineers are very smart, so we know exactly what's right. And so it's going to converge this. And so why do we want to do this? Productivity is king. We saw in the first couple pages that it went from 1 test engineer to 5 test engineers to 10 test engineers. Eventually, that has to roll down to the point where we can orchestrate our test program and we can orchestrate the data with less people, and we don't have to write code because the code is generated. We don't have to write the test program because the test program is generated, but we have to understand exactly what is generated. How is it working? How is it doing this? And then that allows us to focus on optimization. A lot of what I heard over and over through these things was not about how to create content in the test program. It's how to validate that the content is good. It's how to optimize that content for cost, how to optimize that content for quality. And we need to get past this point where we spend our life creating that content, integrating that content, getting the data for that content, and then like 3 weeks after we get a new set of patterns, we actually then summarize the results. We need to get those real-time insights and actually even allow an agnostic AI engine to create new patterns based on, an orchestrator. In other words, I want to target this create the patterns and run them. And it'll go off, create those patterns to target those specific failure modes, get them on the tester, capture the data, and drive it back into the system so that that loop eventually tries to converge. And most importantly, this drives to just faster time to market. So if we can get real-time insights offline, real-time insights online, and drive this into how do we think about what am I working on and how am I working on that data to basically get to the insights. So for me, thinking back in time and thinking over the next 10 years, it's not if this is going to happen, it's just how quickly. And I think of how I started in this industry and about how exciting I felt, the first time I sat down at New Silicon and started working on it and started seeing waveforms and seeing, cause and effect. The same thing is going to happen. It's just going to happen in this different way. And as you start understanding these critical insights, we can start thinking about out of the box as to how do we solve these problems, where now we can really focus on the problem. So with that, I'm open to any questions or comments on my material.
Thanks, Rick, for very interesting and nice presentation. We have time for questions, and we have some micros in the room. If somebody wants to ask a question, can just go to the micro, and I will break the ice with the first question. Partly you answered, I was thinking about the number of people involved in test development and so on. So I was thinking, starting from 1, then 5, then 10, every 15, 20 years. And with the AI, most probably this is going to be getting a little more flat curve. But how about the expectation to have more AI people, data scientists, instead of test engineers? So probably there will be a need for people who knows more about AI, how to use AI, and less about testing. Mm-hmm. Is that good, or there will be some drawbacks? What's your opinion about that?
I think I've heard, depending on the company, whether it's Microsoft or some of the bigger companies that have a fundamental software ecosystem as part of their DNA, they basically saw very early on that they needed like 3 software engineers for every 1 test engineer, so that the test engineer could focus on test with a known good sort of test program creation process. So I think it's good that the test engineers can actually focus on the test. And actually what we see in the discussions and panels, you don't hear a lot of discussion about the ATE. You don't hear a lot about the production sort of environment at the ITC level. You learn more about how do we create patterns, how do we compress patterns, how do we do this. So my expectation is that we'll get to the point where test engineers can go back to like really focusing on test and away from the software portion of the test program. And I've got some colleagues in the audience here that are amazing test engineers, and they're horrible coders. Absolute terrible. And that's fine in 2025 and beyond. And in the past, I had to tell them, stop writing code, just tell me what you want to do, and then we'll get it done. But I think if we can do that, actually Sam Altman earlier this week for OpenAI said that his coders don't code anymore, they just yell at the LLMs. And so he's basically stopped coding, and I think Professor Lee also said that he doesn't allow his engineers anymore to write Python. They have to generate Python. And so I think this is good for test engineers to go back to what our core competency was, which was test, and abstract us away from these distractions of software, you could say.
Thank you very much. We have time for more questions. Very quiet audience today. We have one. Please state your name and affiliation.
Hello, I'm Nigel Gray. I'm a test engineer over at Medtronic. I was curious, we're a highly regulated space, and I was curious how you have integrated your ecosystem into kind of a highly regulated space, if that applies.
Yeah, so for automotive, and we look at the requirements-driven design flow, the concepts that we're driving to were really sort of at that archive state, where in like Copilot, you can ask it to like summarize, the conversation that I've had with you over the last 24 hours. And it'll output the context associated with that so that if you want to throw that into another LLM, you can do that. And so in this regression flow, the key thing that we're looking at there is how do we create like a fingerprint of that test solution that was created at that instance time. And then also like from the universal test spec, and from that, it's like we have all the traceability up there, and then we have the output traceability. So we're using the same fundamental principles that we've used in terms of traceability, alignment, trackability, and that's why I also like the advanced revision control, pattern management. All of these things are super critical. So again, we control the inputs very regulate with high levels of regulation, and we track the outputs with a high level of regulation and analysis. And it's really in the middle there where we don't get into trouble. And that's where a lot of the, call it, productivity occurs. Does that answer your question? Okay.
Hello, I'm Mark Roos of Roos Instruments. The AIs we have today are all trained on historical information, knowledge that we've generated in the past with this somewhat inefficient, as you say, approach of test engineers programming. As we go forward with new technologies and nodes, how do you expect to generate the training material that these non-experts are going to benefit from?
Well, just ask AI to do it. So training is an interesting thing, and we've approached this a lot of different ways. Like with the tooling associated with the AI, we have a whole section with regards to like 1-minute videos and clips that basically walk people through things. And the other thing is we have, call it use groups, that are under a microscope with regards to how are they using the tooling, how is the tooling working for them, what are the results? And from that, and then also the test engineering framework group, which helped me a lot with this presentation and being a sounding board, is it's a central group that allows them to focus on how the tooling fits together, how the ecosystem is generated, how all these things fit together. And then the subject matter expertise that comes out of the tooling then falls onto the subject matter experts. And again, generating that feedback loop that basically says, if it gave me some wrong information, having an AI team or a central team that allows us to then fine-tune that response or figure out what the source of that hallucination is.
Sorry, this is a high mic. I definitely appreciated the ecosystem view and the continuity between all the different domains that have to operate closely together. Can you talk about how you're using data and how you can maximize the data analytics to better inform design, like leverage process learning, based on the framework that you're putting in place? How are you leveraging that to introduce design optimizations and make better decisions earlier in the process?
Yeah, so something that rang true with me during one of the talks yesterday was just design can never tell us how many patterns there are going to be. And once they tape out, then they tell us how many patterns there's going to be. And I've always struggled with monetization of test as it's associated to circuits. And so one of the things from a design perspective that I'm really looking at is grabbing critical attributes of the design and tying them directly to the physical attributes of the test. And then creating benchmarks that allow that to be more like a defect density curve or something similar that allows us to look at things like test efficiency. Like I'm spending 1 second on a SAR ADC test on this technology, but I'm spending 100 milliseconds on the same specs, the same this, the same that in another chip. And these design level views or these vertical views should allow us to basically say from a test time perspective, you know, how much test time is spent on this area of silicon at this technology node. And start us to be, instead of talking about pattern count, you know, we can tie that more directly to like gate count. Or when I look at analog circuits, we have all been there where an analog circuit can be super easy to test or super difficult to test. You know, Steven Sunters spoke a lot about having a deterministic stuck at analog test versus a parametric analog test. And so I think by having this data such that we can monetize the exact time and compare, call it apples to apples, we can then more quantifiably challenge design engineering to grow their circuit a little bit to make it testable, to, you know, do things that allow us to drive this into the design phase. And today I don't have the ammunition at my fingertips to drive these initiatives with the right level of force, you could say. And so that's really how I look at how this data, and we did this to a certain degree already with our platform designs, but it's very ad hoc in how it was done because we didn't have this sort of data lake approach. Okay? Thanks.
Then, once more, thanks, Rick, for your very nice presentation. We have a certificate of appreciation for you.
Thank you. Thank you very much. Thank you.
So, few more information before we can enjoy the exhibit open. About next year, more information will be given at the closing session, but take some notes. For paper submission next year, we will have March as time frame deadline and notification in June. Right, that should be almost all. Now exhibit opens and yeah, enjoy the conference. Thank you very much.